Good evening.
Good evening.
You are facing some issues that earthquake.
But I did not resolve it yet. I will check it on Monday because I modeled two heat exchanger for same season. One is showing and another one is not showing. I will check it up on Monday.
Okay. Might be then if one is showing, one is not showing means it's maybe the software issue.
Yeah.
Ahmad, good evening. You are coming first time, Hasin Ahmad?
Yeah, second time.
Second time. Okay. So you already introduced, right?
Production.
Yeah.
Hey, my name is Hasin Ahmad. I'm working in pressure vessel heat exchanger for a long time.
How many years experience?
Yeah, 3-year experience.
Okay.
In design, 2-year experience in production.
Design and production. So production
Yes.
to 1 year and design 2 years.
Yes. No, 3 years design, 2 years production, 5 years total.
Oh, total 5 years. Okay. Do you have any issues to discuss?
Yeah, actually, I have one requirement. When we use 10 by 13 rule in heat exchanger.
Can you repeat, please?
When we use the requirement of plant ki 10 by 13 rule use in heat exchanger. 10 by 13 rule.
Okay. So, go ahead. What is the question? No.
Yes, 10 by 13 rule.
Yeah. Acha. So this is for the thermal design part, no? You are asking.
No, actually, no client say कि in this heat exchanger vendor to consider 10 by 13 rule also.
Yeah. So this 10 by 13 rule is like this. To suppose if the let's say your design pressure on shell side is 27 bar. Okay.
Yes.
And whereas your shell side is 10 bar. Okay. So if you apply 10 by 13 rule, the lowest pressure should be 10 by 13 of the highest pressure. So even though your shell side design pressure required is 10 bar, if you apply the 10 by 13 rule, it will be 27 into 10 by 13. So you should give minimum around 21. It will come approximate. So this is like this. So in your case, what are the design pressures?
Actually, right now I have no PDS. That's why.
Yeah, but what is your query? You don't know the 10 by 13 rule, or you want to arrive the some value? What actually?
No, I want actually I don't know about 10 by 13 ki,
Okay.
that's why I was not know ki in 10 by 13 rule there is used in pressure design pressure in tube side or cell side. That's why I'm asking.
Okay. As Ramakrishna told that
But
it is.
already done.
Yeah.
In this case, we have to change the design pressure also if we apply 10 by 13 rule.
Yeah, you need to change the design, increase the design pressure of the lower pressure. Yeah.
Okay, maybe yeah. Some actually I search in net also. Then he said tube rupture something. If my cell side pressure is maybe 20 or a tube side is 10, then cell side pressure will act on tube. Then it may be rupture. Then there will be apply on 10 by 13 rule. Then if my tube side tube pressure is 10, then multiply 10. Where we will multiply 10 by 13? In cell side pressure or tube side pressure?
In your case, what's your design pressures? Give an example.
If example tube side is 10 kg and cell side is 20 kg, let's say, then the cell side pressure is more and tube side is less, then fluid will act on tube, then maybe chance to rupture. Then we will apply 10 by 13 rule. Then what pressure we will change?
Wait. Actually, there are two things. One, even if you don't apply the 10 by 13 rule, if you design properly, so there will not be any rupture.
Okay.
So but this 10 by 13 is some recommendation from the based on process point of view and maybe mechanical, maybe based on the experience, they want to have a lesser pressure difference between the both cell and tube. So here how to apply is, whether it is shell side or tube side doesn't matter. Whichever is design pressure is higher. Okay. So that value remains same. So in your case, shell side you are saying it is 20 bar. So 20 bar will remain same. And the lower side, which is tube pressure in your case, that you need to multiply with the higher value, that is 20 bar into 10 by 30. So that much minimum you should keep it.
Okay, 20 into 10 by 13.
Yes.
So 20
So that is 200 by
200 by 13. There 1 0 check it on
15.
So that much minimum you need to keep it. Okay. So so that is as per a specification.
Then 15 what will be 15 tip at pressure.
Yeah, that's all. Whether it is inside or actually, whichever the lower pressure is there, that unit increase by 10 by 13 of the higher. It applies to the both. In your case, here it is
10 by 10. Yeah, the 10 is tube. The 10 into 10 by 13.
No, 20. Actually, as Ramakrishna is telling that, you have to take the where you want to apply. You have to apply for the lowest. Means in your case, it is tube side you have to apply. And
Yes.
the value which you have to take, it is for the shell side. Means 20 into 10 by 13. And whatever the value comes, that you have to apply on the tube side.
Okay, then 15 will come. Yeah, 15 has come now. So 15 will into tube side pressure.
Yeah, tube side pressure. You have to apply that 15 on the tube side.
Okay, and 20 on cell side. Then it will be good, na?
Yeah, cell side whatever will be, means higher whichever is there, you have to keep that one only. And the
Okay,
which is
then
lower.
20 into 10 by 13, it's 15.
Yeah.
Then we have to design 15 kg pressure up to for tube side.
On tube side, whichever that is, tube side is lower in your case, so you have to apply that tube side lower. If you check your data sheet, if shell side is lower, then you have to apply that on shell side. If it tube side is lower, then you have to apply on that tube side.
Okay, thank you so much.
Okay, you got it.
Yes, sir.
Any specification? 10 by Atul.
No, sir. The 10 by 13 rules are only for even if the pressure of the lower side rise to match with the higher side, and it will not exceed the pressure type limit.
Yeah, but you come across such requirement, no, in your
No.
nothing.
No. It's a process requirement. We did not go through. Still.
Oh.
We take care in thermal, but in mechanical design we can't.
So
Okay, as a mechanical engineer, as a mechanist, we have not considered any 10 by 13. Is process?
No. It's a process part.
Okay.
And it is dependent on the area also. If we increase 10% area, it transfer will automatically increase 13. I think 1.3 times.
No, Atul, no.
Yes, sir.
There is nothing to do with the sizing.
maybe it's a specification whatever they say is, if want to consider like what he received is client saying that to be applied means it comes maybe the mechanical maybe.
So it is nothing to do with your area. Okay, it is only just design conditions.
Yes, sir. It's a design condition.
So operating conditions will be same.
Mhm.
So for the sizing of the heat exchanger, it will be only they will consider only operating conditions. Okay, this is only for the mechanical design conditions. This rule is applicable. Okay, not related to the sizing.
Okay.
You got your answer.
Yes, sir.
Okay, Ramesh, do you means yeah, you have something?
Yeah.
Yeah.
Continue. You are asking something.
Yeah, actually, I am asking that one. This is as he said. This is even after giving the in data sheet, if client says that to be applied this one. So after there is some value for the tube side pressure. Also, there is some value for shell side. So after that, you have to apply this value, right?
Actually, this is as I told, who are doing the thermal design? The thermal designer responsibility to give the correct values
Uh-huh.
to meeting the specifications. If he gives the wrong, it has to be corrected. I mean,
Okay.
if 10 by 13 is applicable, so generally for oil and gas, it is applicable.
Okay. So might be then he got the data sheet. Hasin, did you receive the data sheet there?
No, right now I have no.
Okay. So
Maybe
might
I have any
be
MR comment.
okay. So might be data sheet normally they used to provide these values. No? So might be he not received. So that's why maybe client asking to he to arrive this value. Okay. Check with your process also whether they need to consider this one values. Okay. Okay.
Yes.
You got it?
Okay, actually, this question too is Atul. Atul, have you done any exchanges with expansion joint recently, or
Yes, sir. Yes, sir. Yes, sir. Recently I did.
in my case, there is one in how much temperature difference you are getting this expansion joint?
Sir,
Mean
approx
metal temperature
181 main metal temperature approx 150 degrees Celsius.
difference
Yes, sir. Different.
150.
Yeah,
So
150.
actually, currently one heat exchanger need to be designed, and we given to we subcontracted him, or subcontracted to him.
Yes, sir.
So the temperature difference is not much, around I think around
Yes.
60, 70 like that only. So
Yes, sir.
so I mean I checked myself, and it is passing without any requirement of expansion joint. Only I need to increase the tube sheet thickness slightly. So
Yes,
maybe he
sir.
has
It will
considered
pass.
55.
It will pass.
Yeah. So if it is 55 and I made it 70, then it is passing. But he was saying that some upsetting conditions also need to be considered. So that's why it is required. He's saying. Is it correct? Like
Yes, sir.
startup.
Yes, sir.
Yeah.
Startup and shutdown condition there we have to made 4 to 6 conditions, and we have to recheck it on that condition.
So how this is different from the ASME conditions?
Sir, it is not a HME condition. It's like a client's requirement because we have to check the startup
No.
condition.
I'm saying these requirements, how it is different from ASME. So
Yes, sir.
I mean-
Because which temperature we are assuming right now, it is a design temperature, but we have to check. We have to. Am I audible?
Yeah.
Yeah, so because 60, if we assume 20 degrees Celsius on cell side and 65 degrees Celsius on tube side, it will pass. It is not a major issue. But in operating condition, there is a temperature we use. It is the inlet and outlet temperature.
correct. Okay.
And it will vary, and because this variation will come approx 150 degrees Celsius plus, because we have to use this cell side, tube side total all of 4 total divided by 4 is cell side inlet plus cell side outlet divided by 2. This variations are comes for expansion below.
I mean, let's say my inlet temperature is let's say 150 degrees centigrade,
Yeah.
and in the startup condition, cell side, you mean it may not be there. Maybe
Yeah.
maybe it is atmospheric. So then
Yes, sir.
I need to consider the difference of 150 minus 25. So then 125 degrees centigrade difference will.
So cell
Is
side,
that what you asked?
yes, sir.
Yeah.
We have to play with inlet and outlet temperature for cell side, and for some conditions like shutdown condition, we have to use min metal temperature, cell side inlet plus cell side outlet plus tube side inlet, tube side outlet divided by 4 for both sides.
So if you consider those conditions, then it will come.
Yeah, it will come.
Mandatory.
It will come in. It will come on in some, I think, in startup or shutdown condition. I will share you my specs for this. We have to follow only for fixed tube sheet exchangers.
Yeah, it is for fixed tube only.
Yeah.
Yeah. In our spec also it is mentioned, but we can avoid these conditions, I think, right?
Yeah, you can. Yes, sir. You can avoid it because process can give you another condition, another min metal temperature sometimes.
Yeah. So they given for the operating condition, but actually it is whether we need to in the design whether if the process can waive this requirement.
Yes, sir. Process can. Yes, sir. I also did this process. Said me there is bellow coming in startup condition. He said this is not our requirement. You can skip it.
That's what.
Yes, sir.
Okay. Yeah, yeah. So process can waive it, right?
Yes, sir,
that
process can
condition,
waive it.
huh?
Yes, sir.
Correct. I understood. Yes. So actually, previous project also that requirement was there, but we skipped it. I mean, our process said it is not required. Yeah, but here I need to check with the process department. Yeah, then we can waive this. Yeah. Okay. Yeah. Thank you. Yeah.
What actually, Ramakrishna, your issue is bellows are required or not required? What actually?
Yeah. Actually, what happens? See, when operating condition, it is fine. Your temperature difference may not be there. In the startup condition, what happens? Maybe one side only operating fluid will be there. Let's say it is 150 degrees centigrade, and the other side, I think may not be any liquid, or even if it is very low temperature, something like that, then your difference will be huge. Correct?
Yeah.
Yeah. So in that case, I think there is I mean, if you consider that, then I think there will be this difference will come.
So bellow
but if
requirement
process-
comes on that time, right?
Yeah.
Okay.
Yeah. These are extreme conditions. But if process says it is not required, so we can waive that.
Yeah, but this can happen, no? Whenever maybe there is some problem in the in maybe the other side, the fluid it may not flow. On that time, this extreme condition may happen, no? So
May happen, but I think maybe that instrumentation controls will prevent this.
yeah, if everything is okay,
Warning
then
shall be applied.
Yeah. Sorry.
As a warning for if we are skipping some error, we have to provide it as one warning for the heat exchanger.
Correct. Yeah, I think that's what that process philosophy. So when they give that what is called that instrumentation and control philosophy, so I think in that if it is already there, I think they can skip this. Yeah, like that. So what is called control narrative, they call it.
okay, if instruments or everything works well and good, then but okay, but maybe this extreme, extreme.
We have to trust instruments, otherwise your plant will be huge.
Yeah, design will be used.
No, your overall plant will be huge.
But actually, this type of issue, no, this HEC when they are doing this,
Hajab.
Hajab, and that on that time they will Hajab. On that time they raise these issues. If nothing happens, then what will do?
Yeah, I mean, they are experts. So what can happen based on the previous experience? They will say this wall is required, this instrument is required. They will add maybe PSV is required.
Yeah. Additional things they will keep adding that one. Okay, however, you can discuss with your process. If they agree, then you can move forward. What your process, if says that process, you have to increase that pressure, will increase. We add the instrument, we'll add one more nozzle like that.
Correct.
Okay, good. Okay, any further? Any more?
Sir, I did six heat exchanger for which we have to operate nitrogen first, because we have to delete all oxygen inside it. Due to this, we have to paint a warning before operate, just to go through nitrogen first, otherwise it will blast.
Didn't get you. Means you are asking or you're telling your issue?
I am telling about, I am adding some words as per Ramakrishna sir last sentence.
Yeah.
Okay, so
what is it actually? If for nitrogen, during the startup they will add put the nitrogen.
Yeah. For startup, they have to put nitrogen first, deleting all oxygen from inside the equipment.
Oh, okay. If the oxygen is present, then it will.
It will blast.
What is the fluid actually?
Fluid, I think I did not remember.
Maybe sulfur.
I will check it out. Maybe sulfur. Yeah.
Means sulfur, if oxygen there, then sulfur react with oxygen and then it get blast.
Yeah.
So that's why you have to first purge nitrogen, then
purge complete oxygen from
okay, you have to remove. But this nitrogen also they will fill when transportation on that one equipment from one place.
Yeah.
On that time also they'll.
Yeah, but during commissioning, nitrogen will also oxygen can go inside the equipment.
Okay.
No, there are some softwares for shell and tube heat exchanger, I think there used to be micro proton. I think now the name changed. Where if you do the, if you do the thermal design, so based on that it will do the mechanical design calculations, and drawing also will come perfectly for shell and tube heat exchangers.
No, I see. I didn't hear that name, but if you say the compress and PV light, they have that capability. Okay. So there is another for compress also, and for PV light also they have an integration. PV light have integration with Autodesk Inventor, and there is another compress also have some integration with SolidWorks as well as Autodesk Inventor. The issue is, see, when you are talking about the detailing, okay, getting the drawing, you need more compatible. I mean to say, not compatible. You are like more customization.
Exactly.
Okay. When you need the automation, you also need the customization capability. So now, whatever I am now talking about PV Light, which is integrated with the SolidWorks as well as Inventor, that is not compatible or customizable. Okay, you do, then you extract and you import, you get a model, you then, but as I said, it is not customizable. You want to change the manhole again, you have to do some your homework on that. So then this integration will not succeed in India because the varieties, India, and the cost effectiveness. So there is, at least in India, there is no such you can say software which is giving you what you need. Okay.
Yeah. Yes.
So what you need, maybe you will get some automation, but that is not your end result. You will not get the end result. Again, I said, suppose you extract, then import, then you will get a model. Now a guy is required to change it, and that guy has to be like CAD enthusiastic. Like he has to be like very much compatible with the CAD software.
Yeah.
So in India, you are telling it's not available, but in outside, is it available like this? The customized output required.
Customized output outside, I am not that much sure, but the research what I did in India, as per that, I found that it is not available.
I think in foreign also it's not available till now. I think so. Because
in India it's not available, and I'm not telling even available. I'm telling that most of the people are not ready to use it also. So because it's difficult. It's need a transformation. Okay, whenever I talk to clients, so they normally feel it's like it needs some transformation because it's they have to not the thinking. It's like, as I said, the management always think about the cost. Okay, so now if you say Mercedes you are running, right, so fuel consumption is the issue for you.
Yeah.
Okay, so from the management point of view, they will think I need 20 kilometer per liter. So the Mercedes cannot give it. Okay, and it's your not requirement because driver is not compatible maybe with that. So these things are like need some transformation. Like it was like anybody can make some document, right?
Yeah.
And now the authentication problem came. Which one is the correct? So now another problem came, like somebody has to review, then sign, checker, then they have to put the document. You see the mechanism so difficult. Like you are doing in Google, right? When you search, you think there are so many pages are coming.
Yeah.
So the question comes, which is authentic?
Yeah. We don't know which is authentic.
So you have to search 10 pages, you have to find the correct answer. Then you have to put your thinking also, okay, maybe it is correct. Then you will go, okay, now some documents, the proven technology or proven documentation. So ASIM is like proven, for example, ASIM is telling I am a proven one. For like, so then you will blindly follow, okay, ASIM will tell, okay, some Russian code, the ghost, they will say I am the proven one. So it is like up to the user, right? If you have any question you can ask regarding this.
So Ramakrishna, your plan is just to make calculations, right?
Yes.
In future, maybe. So that can be you do by using Excel also, no? Why you want any software or anything?
I know I have to do the calculation, then I have to talk to my draftsman, then they will give some output, then I have to check those. And then my material guy will ask me this question, this material is not available, so he will say some changes. So it's like everything I know, but now when I enter to this field, I don't know lots of things.
Yes.
So that's the challenge. So maybe after 5 years, we'll feel okay. This is feeling bored, so I need some changes. So that time only, it's not like job is there in the market nowadays. Also, it's not like the no job.
No. After 5 years, we don't know. So that's what.
It will be there. You see, that is called human emotion. You cannot break it. Right? But
No, actually, Ramakrishna, after 5 years, you are telling about your retirement, or you are due to the AI coming inside?
Yeah, maybe something like maybe early retirement kind of thing. I don't want to do the job, regular job.
Okay. So your retirement, not for the AI entering or something is coming new. Not
Yeah.
that. Okay.
So something maybe I think we should be there. I think
Yeah.
maybe.
no, that is a fact. I am telling you. Another 10 years, there will be revolution. See, what will be the issue regarding this AI? There is only one thing is missing is the human touch, the emotions. Okay,
Correct.
the work-wise, it will be better. Obviously, the company expectation will be much more higher from the output point of view, or you can say effectiveness or efficiency.
Yeah.
Okay, so that can be after 10 years, it can be calculated. Nowadays, frankly speaking, most of the companies you cannot calculate the man hours. I'm telling you, it's not possible. But the person what he is doing, you cannot measure it actually. So you can say, okay, guy X can complete this project 6 months, guy Y maybe 7 months. But it is not necessary the guy Y cannot complete in 6 months. He also can complete. Maybe some hurdle comes in between.
Yes, sir.
Okay.
Yeah.
But when this 10 years, this AI will come, so you can measure it. Maybe the AI will complete the work in 1 month.
Yeah.
Okay. So then you maybe as a human, you can take 3 months, but not 6 months.
Yeah.
Okay.
Yes.
So that's the challenge. And it will change. Drastically, it will change. Next 10 years, huge changes will come.
And one more thing, we as a humans waste lot of time. I mean.
No, that is called emotion, right? We check the messages. So you cannot ignore those. Like some message comes, you open the mobile. So AI will not do that.
Not only that, actually, not only messages. Actually, in the industry, what's happening? See, you have to work on a particular target. Okay, so some task is given, but in between something from somewhere another demand will come. I need this urgently. But
correct. So that will again your brain will drastically change. Yeah. So as I said, right, when I'm doing the calculation, suddenly the material department will come and he will change this material not available.
Not available. Yeah.
And now you have to find out the correct material. So that is totally changed, right? Your calculation suddenly you did lots of things and suddenly you have to change again. So those things will be obviously there because that is the cost to cost company, right? I mean, so you have to find out the cost. But when the AI will come, those things can be, AI will not listen to you like, okay, you are changing the material. Suddenly you will do it.
Yes.
Okay. So he will not take a pause and again he will not do the argue. I mean to say to the guy who is changing it. Suppose now the client is changing it, you will do the argue. Hey, sir, we did it after 3 months, you were telling me to change. What AI will do? AI will change it again.
Yeah.
So that's the emotional content is missing there. He will not ask you, sir, why you are telling me again we have to redo, man hours will increase, again we have to need 10 hours. And that guy will say, oh, take more. Can you do it 5 hours?
That for the AI as technology advanced, maybe they will put a lot of checks and balances. I think then it will, provided, it should not do this like this, some kind of things. If logic is given, I think then it will ask why you want to do it. Yeah. Probably it may not be right now, but maybe after some time. Yeah.
Yes.
Okay.
Okay then.
Okay, Ravi.
Thank you, Ravi. Krishna, thanks.
Thanks. Good night. Bye. Happy weekend.